Hello and welcome class. So in last class we have studied about what is uniform motion, non-uniform motion and we ended up on this topic speed. In today's class we will continue understanding speed and then we will learn about a new topic known as velocity. So let's understand speed through an example. So let's understand speed by an example. An example is a car traveled a distance of 100 kilometer in 2 hours. Okay, a car has covered 100 kilometers in 2 hours. Okay, so maybe in first second its speed will be 0. Okay, 0 meter. In second its speed will be 10 meters. In third second uh, its speed will be, let's suppose, 5 meter. In 4 second that its speed might be 20 meters. Okay, so this car is not constantly moving with a speed of 2 kilometer per hour, 20 kilometer per hour, but its average speed, what will be the average speed? Total distance divided by total time taken. And what is the total distance? Total distance is 100 kilometer. The total distance is 100 kilometer. Total time taken is 2 hour. The total time taken is 2 hour. The final answer is 50 kilometer per hour speed. Okay. So this is its average speed, but this car might not be traveling with this speed in every second, because here its speed is 0 meter per second. Here its speed is 5 meter per second. Here its speed is 5 by 3 meter per second. So if we check every instant, that every instant has different speed. But on average, this car is moving with a speed of 50 kilometers per hour. Is it clear, class? The car might not have traveled at 50 km per hour all the time. Sometime it might have traveled faster, sometime slower, but on average its speed come out to be 50 km per hour. Okay. Okay. I also want to explain you that you can easily change kilometer per hour into meter per second. 1 kilometer per hour is equal to 5 by 18 meter per second. Okay, you have to remember it if you want to change kilometer per hour into meter per second directly. I will show you the derivation. The derivation is 1 kilometer per hour. Clear, class? How much kilometer is there in meter? How much meter is in 1 kilometer? 1000 meter equals to 1 kilometer. And if I want to change r in second, then I know that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. And when you solve it, 5, 3, so it will become 5 by 18 meter per second. So 1 kilometer per hour is equal to 5 by 18 meter per second. If I want to change 50 kilometer per hour, then it will become 50 into 5 by 18 meter per second, and we have to solve this number and we will get answer in meter per second. Is it clear, class? Now let's solve some example. Example 7.1, and what this example says: an object travels 16 meter in 4 seconds, then another 16 meter in 2 seconds. What is the average speed of the object? An object travels 16 meter in 4 seconds. Then the object accelerated and it covers 16 meter in just 2 seconds. So what is the average speed of the object? So what will be the formula used? Formula used is average speed is equal to total distance divided by total time taken. Total time taken. What is the total distance here? Total distance is 16 plus 16. And what is total time here? Total time here is 4 plus 2. You just have to solve this. First add and then divide and you will get correct answer in meter per second. Is it clear, class? Let's see the correct answer, complete answer. I hope the approach is clear to all of you. Okay, so the solution is total distance traveled by the object is 16 plus 16, which is 32 meter. Total time taken by the object is 4 plus 2, 6 seconds. What will be the formula of average speed? Average speed is total distance divided by total time taken. Total distance is 32 meter. Total time taken is 6 seconds. And final answer is 5.33 meter per second. Is it clear, class? I hope the solution is clear to all of you. Now let's understand a new topic, which is speed with direction. I have explained to you before that speed does not have any direction. But what will happen if I include direction as well as speed? Then what will it become? It will become a new quantity known as velocity. So speed with direction is known as velocity, and it is very important term in physics. Okay, and now we are going to study velocity. So velocity is just speed with direction. And what is the definition of speed? Speed is distance divided by time with direction is known as velocity, or the rate of motion of an object can be more comprehensive if we specify its direction. Okay, the rate of motion will be become more specific if we include the direction along with speed, and the new quantity is known as the quantity which has both the aspect is known as velocity. What it is known as? It is known as velocity. Velocity is the speed of an object moving in a definite direction. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. Variable means non-uniform. Same like speed, nothing different. We are just calculating speed in one definite direction and we called it as velocity. Okay. Speed in one specific direction is known as velocity. It can be changed by changing the object speed, direction of motion both. As velocity includes speed and direction, so if we change the direction, the velocity will change. If we change the speed, velocity will get changed. When an object is moving along a straight line, similar like concept of distance and displacement, when an object moves along a straight line and does not change its direction, distance is equal to displacement. Similarly, when an object moves along a straight line, speed will be equal to velocity. We can express the magnitude of rate of motion in terms of average velocity. When an object moves along a straight line at variable speed, speed is varying, okay? And the object is moving in a straight line. So similar like the concept of speed, that when speed is changing in every instant, we introduce the concept of average speed. Similarly, we can introduce the concept of average velocity. It is also calculated in the same ways as we calculated the average speed. In case of the velocity, object is changing at a uniform rate. Average velocity given by the arithmetic mean of initial velocity and final velocity for a given period. Like displacement, same like displacement, which depends on initial position and the final position. Similarly to that way, average velocity also depends only on the initial velocity and the final velocity, and average velocity is the arithmetic mean of initial velocity and final velocity. It means that V average is equal to initial velocity plus final velocity divided by 2. Average velocity is equal to initial velocity plus final velocity divided by 2, and mathematically V average is U plus V, where U is the symbol of initial velocity and V is the symbol of final velocity. And speed and velocity have the same magnitude, that is meter per second, okay? Because direction does not have any units. The in unit wise speed and velocity are same. Similar to distance and displacement are same in unit terms, but their definition is different. Similarly, speed and velocity, their definition is different, but their units are same. Both are describing rate change of motion, but one include direction and other does not include any direction. And formula for average speed was average speed formula is total distance divided by total time taken. Total distance divided by total time taken. Average velocity depends on initial and final velocity, and it is the arithmetic mean. So its formula is U plus V, and there are two terms, so divided by U is initial velocity. When the object is starting, the initial velocity is symbolized as U, and final velocity is symbolized by V, and average velocity is U plus V. Now let's do one activity. I hope the concept of velocity and average velocity is clear to you. Now let's understand it more deeply through an activity. And what this activity says: measure the time it takes you to walk from your house to your bus stop or the school. Measure the time taken by you from your home to your bus stop. If you consider that average walking speed, if you consider that your average walking speed is 4 km per hour, estimate the distance of bus stop or school from your house. Okay? If you consider that your average walking speed is 4 kilometer per hour, okay, so now you have to calculate the distance from your bus stop to your house or to your school. Is it clear, class? You have to measure the time. Okay, measure the time, how much time it takes you to go from your home, time taken to you to go from your house to school, and you have to assume that your average walking speed is 4 kilometer per hour. Then what will be your uh, distance between your school and your home? Okay, so try this activity. Activity number 7.7. There is another activity, and what this activity says: at a distance, when it is cloudy, there may be frequent thunder and lightning. Okay, when there is cloudy, there may be frequent thunder and lightning. The sound of thunder takes some time to reach you after you see the lightning. We know that uh, we have observed that we first see lightning, then we hear the sound, okay, of thunder. We know that. So, can you answer why this happened? Can you answer why you first see the lightning, then you hear the thunder? Can you answer this question? And measure the time interval using digital wristwatch or stopwatch. Okay. When you see the lightning, start your stopwatch, and when you hear the thunder, stop your stopwatch and check how much time interval is there, and you can calculate the distance of lightning by using the speed of sound in air. So the given speed is 346 meter per second, and you have calculated the time interval between lightning and thunder using stopwatch. Let assume the time it taken was 6 seconds. Okay? When you see the lightning, you have started the stopwatch, and when you hear the thunder, you have stopped the stopwatch, and the stopwatch shows 6 second time period. You can calculate the distance of the nearest point of light. Okay, you can try this activity, and the answer that why we first see the lightning and then we hear the thunder sound is speed. So we are here, two phenomena is happening. One is light and one is sound. Okay. The speed of light is very, very, very much higher. It is the greatest speed any person can achieve. And the value of speed of light, which is represented by C, speed of light, is 3 into 10 raised to the power 8 meter per second, and the speed of sound in the air, okay, is 346 meter per second. So we can compare that the speed of light is very, very much greater than speed of sound. That's why we first see the lightning, then we hear the thunder sound. And if you want to calculate the distance of nearest point of lightning, you can calculate using this value of speed, and you can use stopwatch for the time. Okay, I hope this activity is clear to you. Now let's solve some problem. First problem is we have to distinguish between speed and velocity. Okay, so speed is similar, just distance divided by time. And what is velocity? Velocity is speed with direction. Both has same SI unit, but speed only has magnitude. Velocity has magnitude as well as direction. Okay. So this is the table differentiating between speed and velocity. What is speed? Speed is distance traveled by an object in a given time interval. Velocity is the displacement of an object in a given time interval. Okay? Speed is distance divided by time. Velocity is displacement divided by time. Speed has only magnitude, and those quantity which has only magnitude is known as scalar quantity. So speed is a scalar quantity. Distance is a scalar quantity. Velocity has both magnitude as well as direction. So velocity is a vector quantity, like displacement is a vector quantity. So this table differentiate between speed and velocity. Is it clear, class? I hope it is clear to you. Question number 2. Under what condition the magnitude of average velocity of an object is equal to average speed? At which condition? So we know that velocity depends on speed and distance and direction. If v does not change the direction, then the velocity will be equal to speed. So let's assume an object starting from this point moves along a straight line and reaches this point. U was the initial velocity and v is the final velocity. So if this object does not changes its direction, then speed is equal to velocity. Clear, class? So object should not change its direction. Then the average speed will be equal to average velocity. The magnitude of average velocity of an object is equal to average speed only when an object is moving in a straight line. It means does not change its direction. The object should not change its direction, then the average speed will be equal to average velocity. Okay, class? Question number 3 is what does odometer of an automobile measure? And we have, in that example from Bhubaneswar to Delhi, we talked about odometer. It measures displacement and or distance. So odometer measures the distance covered by the automobile. So it measures distance. Clear, class? Question number 4. What does the path of object look like when it is in uniform motion? When an object is in uniform motion, what does the path of an object look like? What will be the correct answer according to you? The object having uniform motion has a straight line path. Okay? Direction is not changing, path is straight line. Straight line path. Because if you try to turn or change the direction, then your motion will not be any uniform motion. Okay, whenever you change your direction, your speed changes and your motion become non-uniform motion. So the path for the uniform motion is straight line path. Is it clear, class? So the correct answer is straight line. Question number 5. During an experiment, a signal for a spaceship reached the ground station in 5 minutes. from a spaceship, a signal from a spaceship reaches ground station in 5 minutes. What was the distance of the spaceship? We have to calculate the distance. If the speed of light is already given and the speed is 3 into 10 raised to the power 8 meter per second. So speed is given, time is given, you have to calculate the distance. To solve this question, first we will convert minutes into second. We know that 1 minute is equal to 60 seconds. Then 5 minutes will be equal to 5 into 60, which is 300 seconds. And then the formula is speed is equals to distance divided by time. V is given, T is given. We have to calculate S. So what will be the S? S is equals to V into T. Okay. So that's how we will calculate the distance. Let's check the answer, detailed solution. Speed is already given, which is the speed of light. We have calculated the time in second and we know the formula of distance. Distance is speed into time. Speed is 3 into 10 raised to the power 8 and time is 300 seconds. So final answer is 9 into 10 raised to the power 10 meter per second. So the distance between spaceship and the station is 9 into 10 raised to the power 10 meters. Okay, we have calculated it in meters. Is this question correct, class? Okay, example 7.2. There are more examples left. So we are going to solve this example in the next class. In today's class, we have studied what is velocity. Velocity is simply displacement divided by time. It's a vector quantity. It has both magnitude as well as direction, or in other ways, it is speed with direction. Okay. So in today's class, we have studied mainly velocity and solved the problem. In next class, we will solve more problems and then we are moving towards the equation of motion. So we will see you in next class. Thank you so much.